today, guys, we're going to work on solving trig equations. We've done these before. Let me show you what I mean with example number 1. We want to get the cosine of theta by itself. So we're going to start by adding 1 and then dividing by 2. Now this looks like the trig equations that we've done before. So now what we've got to think about is in our unit circle, where is x equal to a half? Right? X is a half when our angle is either 60 or 300 degrees. Okay? And that's it. That's all there is to solving a trig equation. You guys try number 2. The answers to your turn problems are at the end of the PowerPoint, so you can check your work. Let's take a look at example number 3. Right, example number 3, we want to get tan of theta all by itself. So we're going to start by adding 3. Now we've sort of got tan theta by itself, but not quite, because that's tan squared theta. So in order to get tan theta by itself, we're going to take the square root of both sides. Right, and that's going to give us tangent of theta is equal to plus or minus the square root of 3. Now remember, tangent is a little bit weird because it's a combination of sine and cosine. So we've got to think about what could be on the top and the bottom in order for us to end up with the square root of 3. Well, the only thing on our unit circle that involves the square root of 3 is 1/2 square root of 3. So I must have started with 1/2 square root of 3 over 1/2, and then we canceled the 1/2s out. So I'm really looking for where sine is 1/2 square root of 3 and cosine is 1/2. And that happens at 60, 120, 240, and 300. And notice this time I've got 4 angles because I had both the positive and negative versions of these. So I want to look at all 4 quadrants. I want to see where is tangent, where is sine 1/2 square root of 3 and cosine 1/2, where is sine negative 1/2 square root of 3 and cosine 1/2, where are they both negative, and where do we have them one negative and one positive. So that means I need angles in all 4 quadrants. Typically, whenever we have that plus or minus, we're going to have 4 answers. Again, try number 4 on your own. Check your answers at the end of the PowerPoint. Let's take a look at example number 5. Right. Example number 5 is similar to number 3. Okay. Right, in the sense that we're using tangent, but this time instead of tangent squared, we have tangent of 2 theta, and you'll see how that changes the answer. So the first thing we're going to do is we're going to add 1. And again here we've got to think about tangent and what could we have on the top and bottom so that everything would cancel out. And in this case, that's got to be the 1/2 square root of 2. That's the only place where both x and y are the same. So in order to get the tangent of 2 theta equal to 1, I've got to have 1/2 square root of 2 over 1/2 square root of 2, or negative 1/2 square root of 2 over negative 1/2 square root of 2. So I'm going to look for where sine and cosine are both 1/2 square root of 2, and where sine and cosine are both negative 1/2 square root of 2. Okay. And that happens in the first and the third quadrant and gives me angles at 45 and 225. Now, I'm not quite done, because notice this says 2 theta is equal to 45 or 225. So instead of just knowing my theta, I actually know what 2 times it is. So in order to actually get my angle, I've got to divide by 2. So that gives me 22.5 or 112.5. Now, in addition, I can get at least 2 more answers here, and that's what makes these tricky. Because my answer is multiplied, I can continue going around my circle and still end up with angles between 0 and 360. For example, I can look at where 2 theta is 405. That's 360 degrees rather, more than 45. So to get that, I added 360 to the 45. Or where 2 theta is 585. Again, I added 360. So I went around the circle another rotation. Okay. Once I get these angles, I divide them by 2, and that gives me 2 more angles that have that tangent of 1, okay, that are still between 0 and 360. So whenever you have these multiple angles, okay, you've got to remember that you can go around the circle more than once. So if you're looking at example number 6, that one you're going to be able to go around probably 3 times and have 3 sets of angles. To go around an additional time, you just add 360 to your original answers. Right. Try number 6 on your own and check your answers at the end of the PowerPoint. Alright, let's take a look at example number 7. Now, as you can notice, these are getting progressively harder, and we're going to work on these over several days. So don't worry, if you have questions, I can answer them in class. The last 2 examples, number 7 and number 9, are both going to involve factoring. So remember, with factoring, we need to think about looking for a greatest common factor first. What do the 2 things have in common? These 2 things have cosine of theta in common. So I'm going to factor out the cosine of theta. So when I factor it out of the first term, I end up with 2 cosine theta on the inside. And then cosine theta times 1 gives me the other cosine theta. So I basically factored this just like I would factor 2x squared plus x. I pulled out the x, and that left me with 2x plus 1. Now, I can't factor anymore because I've got cosine thetas without any multiples. So I'm going to set each of these equal to 0 and solve them. So I'm going to have cosine of theta equals 0, and 2 cosine of theta plus 1 equals 0. And I'm going to solve them just like they were 2 individual problems. So cosine of theta is 0 at 90 and 270. So x is 0 at 90 and 270. 2 cosine theta plus 1, when I solve it, means that cosine theta is equal to negative 1/2. I subtracted 1 divided by 2. X is negative 1/2 at 120 and 240. So I have 4 answers to this problem: 90, 270, 120, and 240. So whenever you have these factored problems, odds are you're going to have more than one answer. Try number 8, thinking about the fact that they have sine of theta in common, right, and check your answer at the end of the PowerPoint. All right, on to one more harder factoring problem, and then we'll be done. Now, this one's harder because it has a sine squared theta, and we don't have sine theta in common in all 3 terms. So I'm actually going to think about this one just like it was a quadratic, okay? Since I have a squared, a single term, and then a constant. So this is really just like x squared minus 3x plus 2. All right, and I can factor x squared minus 3x plus 2 into x minus 2 and x minus 1. Right, so if you want, write it in terms of x's, factor it, and then you can go back and put in your signs. So if this factors into x minus 2 and x minus 1, what we really have is sine of theta minus 2 times sine of theta minus 1. Then I can set each of those equal to 0 and solve them. Now, sine of theta minus 2 equals 0 gives me sine of theta is equal to 2. Well, we're working in a unit circle, and a unit circle only has a radius of 1. So there's no way that the y value can be equal to 2. So that particular part of the problem has no solution. Okay? Sine and cosine can never be larger than 1 because we're working in the unit circle. That's really important. You might want to write that down. Sine of theta and cosine of theta always have to be less than or equal to 1 since we're working in a unit circle. So let's look at the other part. If sine of theta minus 1 equals 0, then sine of theta is equal to 1. Right? Well, y is equal to 1 when theta is 90. So that's the solution to our problem. So this particular one only has one solution, 90 degrees. Example number 10 on your own. Keep in mind with this one that you might want to subtract 4 and have it equal to 0 first. Okay, that way you can factor it like 2x squared minus 7x minus 4. Okay, try that, and again, here are all the answers to the example problems, the your turn problems on your worksheet. Okay? Try them and we'll talk about them more in class. Have a great weekend. Bye.